So here we have a post-tensioned cable of a beam 10 meter long is initially tensioned to a stress of 1000 Newton per mm square at one end. The tendons are curved so that the slope is 1 in 24 at each end with an area of 600 mm square. Calculate the loss of prestress due to friction with the following data which is given. Okay, so now here we are with the example where we need to calculate the loss of prestress due to friction only. Now these examples might come for 8, 10 or 12 marks where only we are concentrating on losses due to friction. What is given is coefficient of friction between duct and cable is 0.55. Coefficient of friction for wave effect is 0.0015 per meter. During anchorage, slip is 3 mm at the jacking end. So we have to calculate the final force in the cable and percentage of loss of prestress due to friction and slip. So important thing is post tensioned cable, first thing. Second is jacking is done at one end only. Okay, jacking is done at one end only. Then slope is given as 1 by 24. The length, cable length is given as 10 meters. Initial stress is 1000 Newton per mm square. So let's get down to the figure. So this is the figure, slope is there, alpha angle, 10 meters length. Okay, so now alpha for this case is 2 times of the slope, that is 2 into 1 by 24 which is equal to 1 by 12. We can keep it as it is, no problem. Then P, that is the stress, is 600 which is the area into 1000 which is the applied stress. We are dividing it by 1000 to convert it to kilonewton. That is the pre-stressing force is equal to 600 kilonewton. The value of K is given as 0.0015 per meter. Value of mu is equal to 0.55. So firstly let us estimate the loss due to friction. We can use the formula directly which we had in that summary sheet. P naught into bracket mu alpha plus kx. Substitute the values. Now P naught is what? Stress at initial stress. Okay, it is not the force. P naught is the initial stress. Here we are finding loss in stress. Don't substitute 600 in place of 1000. We have to substitute the initial stress, that is P naught is 1000. Mu value is 0.55 sorry. Alpha is 1 by 12, K is 0.0015 and X is the length. Here in this case X is equal to L because jacking is done from one end. X is equal to L. Therefore in place of X we are substituting the value 10. So we get loss of stress due to friction as 60 Newton per mm square. Next, loss due to slip. So we are using the formula of delta. Any formula you can use, or you can directly also find the slip. So here they have gone, firstly they have found out P. P is equal to delta, that is 3 mm, into area is 600. E is 210 into 10 raised to 3 divided by length in mm, 10 meters into 1000. So we get P as 37.8 kilonewton. Again they have divided by A. So again I am repeating from the summary. You can do this stepwise as given in maximum of the textbooks, or directly also you can find the loss due to slip. So we get that loss as 63 Newton per mm square. Therefore loss of force due to friction. Okay, how much force is lost? the stress let us convert into force, that is loss is 60, we are multiplying by 600 which is the area, so we get the answer as 36 kilonewton. So out of 600 kilonewtons, 36 kilonewtons is lost by the frictional effect. 36 kilonewton is lost, and the value because of slip we get directly in kilonewton itself, which is 37.8. okay, which is 37.8. so both the losses, that is 37.8 plus 36, account for 73.8 kilonewton. Therefore the final remaining force, okay, therefore the final remaining force is 600 minus 73.8, which is equal to 526.2 kilonewton. So out of 600 kilonewton, which was the pre-stressing force applied, we are left with only a force of 526.2 kilonewton. Okay, so now this is how you will be estimating the final pre-stressing force left out after taking into consideration frictional loss as well as loss due to slip. Now percentage loss of stress, the stress lost is 63 by slip, and the stress lost is 60 because of friction. So 60 plus 63 divided by 1000, which is the initially applied stress, multiplied by 100 gives us a value of 12.3%. So from the total 100% stress, which was 1000 Newton per mm square, we are losing 12.3% of stress because of action of friction and slip. Okay, so here we have solved two examples. We have tried to cover all the parameters which can come in the examples. Okay, so in first examples we accounted for losses at initial stage and later stage. In the second example we concentrated on losses due to friction and loss due to slip. So I request you all first to go through that summary sheet, make a list of formulas, understand which formula comes where, then next go through these two examples and practice them. So we'll conclude for the day. Thank you.